Confirm, any one of you? Yeah. Yeah, okay, thank you. So today we'll try to cover the 5G core. So 5G core session is divided into 4 parts. First 3 parts will be taken by myself, and the last part again by C dot uh, person. And in part 1 today, I'll cover these 4 items. The first, I'll be covering high level 5G system, which we have seen earlier. And then what is 5G reference point architecture? We will have a look at that. And then we just understand basics of what is protocol data unit sessions and quality of service flows in 5G. And then the main network function elements of 5G will see the functionality of each one of them, starting from AMF, that is access and mobility function, then session management function, then user plane function, policy control function, and unified data management. So we'll talk about that, and then you will be able to correlate with the mobile technology you may be knowing as of now, 2G, 3G, 4G. We'll be able to compare with that, what is the equivalence and the difference. So let us start with high level 5G system. So as in any other, let me take the pointer. As in any mobile system, it consists of one is the radio part. One side you have device, then you have air interface and the radio part, and then you have core network, and then finally data network. So as we know that in 4G and 5G it is a pure kind of a data network, so there is no a circuit switch voice concept as was there up to 3G. So the NG-RAN, a new generation radio access network, or sometime it is called NR, new radio, or it is also called gNodeB. So this we have covered already. So in 4 parts, air interface, 4 parts we have covered. So today we'll try to cover some part of 5G core network. So this entire thing is called 5G system, 5GS. So wherever nomenclature 5GS comes, it is 5G system, which consists of the device plus the radio part, core, and the data network. So now let's look at 5G system architecture. So you just look at this particular diagram, and I'll try to explain these. So first of all, we should be aware about different network functions. The name, all these namings are completely new. It's a new architecture of 5G. So the user equipment, starting from this is your user equipment. It could be a mobile phone, it could be any kind of device or machine or sensors. Onto the radio side, RAN, radio access network, which is also called new radio or NG-RAN, and we also call it gNodeB. In 4G we used to call eNodeB, here we call it gNodeB. G stands for next generation node B. Now the next element is your AMF, access and mobility function. It is equivalent to MME in 4G, mobility management entity in 4G. In fact, some part of that. And then this one is SMF, session management function. So in 4G, MME itself used to do session management. So in fact, the MME has been split in 2 parts in 5G, AMF and SMF. And of course, AMF will take over certain function, control function, which used to be done earlier by serving gateway and PBN gateway. Moving to this one, there is a single network function called UPF in the user plane. So this is user plane function. So all those packet routing, filtering, etc. is done by UPF. And then we have a policy control function. PCF is nothing but policy control functions. The equivalent in 4G was PCRF, and this one is UDM, Unified Data Management. So all those HSS which was in 3G, so it is analogous to that, not really equivalent. It is kind of analogous because function wise it is slightly different. And now what you see here in blue color, this is very important, please, is kind of when there is a data flow, when is a data traffic, the data traffic flows onto this blue pipe called PDU session, protocol data unit session. P is the protocol here. Sometimes people call packet, but the actual name is protocol data unit session. So protocol data unit session is nothing but series of connections from user equipment to gNodeB to UPF and then to the data network. So this series of connection is called PDU session, and all the data traffic flows through this, and all the other elements are actually help or facilitate this PDU session to be established and to be maintained even when the UE is moving from one gNodeB to other gNodeB area. And then finally we have a data network. So as we had discussed in our earlier sessions that in 5G it is called data network, in 4G it was packet data network. So in 4G the data was always a packet data network, but in 5G it could be a packet data network, it could be Ethernet, it could be unstructured or structured data flowing onto this. So that's why we call it a generic name data network. For example, the example of this data network could be IMS to support voice over IP or voice over new radio, or it could be any AR/VR service, or it could be internet, which is mostly used. So the data network. Now moving forward. So this is some kind of analogy in a chart form that how 4G and 5G are equivalent or what is analogous to each other. So on the top side, the network element which you see is of 4G, where we had MME. If you recall, when we did evolution of technology, there we had seen MME is mobility management entity. This is serving gateway which connects all those data traffic flows through this from eNodeB to serving gateway, and PDN gateway, serving gateway to PDN gateway, and from PDN gateway it goes to the packet data network. So PDN gateway, HSS equivalent to HLR, PCRF as I said, and application function, and there are certain new network element in 5G which is mentioned here. So what is, as I explained, that MME is kind of a split into AMF and SMF, but SMF will also take some control part of the function of PDN gateway. UPF is nothing but the user plane part of serving gateway and PDN gateway in 4G, and PCF in 5G is equivalent to PCRF in 4G. And then these elements which we'll be discussing later, but this is authentication server function, authentication service functions, which was used to be done by HSS earlier, and the UDM, Unified Data Management part, was also in the HSS in 4G. And these are the new network element like application function, network exposure function, network repository function, and network slice selection functions, which we will talk about later in the slides. So now, as I said, that the data flow in 5G is through the PDU sessions created for each of the UE, and there is a quality of service flow inside the PDU session which makes a particular traffic flow onto the 5G system. So let us talk about that, and this is important. I seek your attention. So as I explained that this blue pipe is nothing but series of connection, and onto this data flows. So this is called PDU session, and this part UE, gNodeB, UPF and towards data network is actually the user plane part, and rest are part of the control network function like AMF, SMF, UDM and PCF is part of control function which facilitate this PDU session to happen for the user equipment. So now let's see this. So as I said that for every UE, whenever it want to communicate or use data service, a PDU session is created for that particular UE, and onto that PDU session it gets connected to the data network. And so the PDU sessions are basically unique to a particular device, and PDU session, as I said, is nothing but series of connections from UE to gNodeB to UPF to the data network. So now if you have one device, it may be using it for multiple type of data. I mean, so it could be uh, uh, internet data, it could be a voice call, or it could be a video streaming. So there could be there is a possibility that even simultaneous this device will be using multiple data flows requiring different kind of quality of service. For example, if uh, this is kind of a, using just an internet browsing kind of a service through the internet, so that means the quality of service is a default quality of service, which is kind of, we call it best effort basis. Whatever is possible by the network, that is allocated. So whenever UE actually gets activated in the system, it is allotted a default quality of service flow initially. So, and how do you identify that? So within the PDU session you have quality of service flow. So how do you identify a particular flow, whether it's an internet traffic or it is a voice call or it is a video call? So there is a concept of QoS flow ID. So every type of QoS is assigned a QoS flow ID. For example, if it is a default QoS flow, so a ID for default QoS flow will be assigned, and the traffic, so all the traffic which is a internet traffic, a plain internet traffic, will simply be mapped to this particular QoS flow or the default QoS flow onto this PDU session. And if there are, say, voice call which will require some kind of guaranteed bit rate, it will have a different QoS flow ID. So basically the traffic which flows to the network are actually the flows. So those are categorized by the flow. So one type of traffic will flow with one QoS flow ID kind of. So assume that this PDU session have currently a default QoS profile, because initially a default QoS flow which do not have a guaranteed bit rate, but it's a best effort, is kind of allocated to the device. And later on, when the device requires a different kind of QoS flow, say requiring guaranteed bit rates, then other type of QoS flow is allocated within the same PDU session. So what will happen is that the PDU session will contain n number of QoS flows having different QoS flow ID. Some could be guaranteed, some could be non-guaranteed, and that will flow onto the same PDU session. So the resource gets allocated onto the radio depending upon what kind of QoS flow getting assigned to the this particular PDU session or call particular flow. So a PDU session is a kind of transient in nature, in the sense that a the QoS flow, the QoS flow is transient in the sense that a particular QoS flow can be added, a particular QoS flow can be modified, or a particular QoS flow can be even removed or turned down, right, depending upon what is the status in the network. So Why I explain that? Because the entire thing in 5G or even in 4G is a data traffic and that is to be maintained. So after giving that idea, let us go through each and every network element of 5G one by one and understand what is the function it plays, the broad function it plays. So now we'll start with AMF. So AMF, the full name of AMF is Core Access and Mobility Management Function. So Access Mobility Management Function. So we call it Core Access and Mobility Management Function. So as the name suggests, so it plays a role in access. So initial access onto the network is handled by AMF, and the mobility part, mobility management, is also done by AMF. So if you look at this, so mainly we are talking about AMF, access and mobility functions, this particular network element. So before we proceed, just have a look at this. So as I said that the AMF is mainly for access. So basically the registration and security, the access to the network for any device or mobile or user equipment is handled by AMF. So that is registration and security. And second is the mobility part, mobility of the subscriber or UV or the device is handled by AMF. So to just explain this to you, so AMF, if you look at this pointer, so whenever a mobile is active, suppose a mobile is active, it is using a data call or a voice over NR. In that scenario, in fact, AMF knows the location of the device, in which cell the mobile is located currently is actually known to AMF, because then only it will be able to serve. And in case the device is not active, it may be an idle. In that case also AMF knows the tracking area, in which tracking area the mobile is located. So let me ask you, what is tracking area, by the way? Any of you? Right, sir. So tracking area is kind of a set of gNodeB area or cell area in a sector area. So it's a kind of a cluster of that where subscriber is supposed to be present, is called tracking area in 5G. And tracking area in 5G is so there is also concept called registration area in 5G, which is slightly different from 4G and 5G. So I'll just give you one example, that suppose a device is a sensor and has been installed in a bus, which route is fixed. It is starting from X point in a city and going to the Y point and coming back. So the entire area is kind of may consist of more than one tracking area, but it will be a single registration area for that device. So the registration area in 5G is a kind of a specific area which a particular mobile is following, for example that bus. So there is a possibility that in 5G, while provisioning a device onto the system, I can provision that the registration area is this for particular device. That is one. Second is that in 5G network, it can learn that what is the set of tracking area normally a device is moving in a day. So it will set that as a registration area. So one is provisioning based, other is learning based, or there is some default registration area which is equivalent to the tracking area. So the AMF knows at least the tracking area or the registration area in case it is not active, and if it is active, it even knows the potential cell where the device would be, because it handles mobility, so it knows that. Now the AMF also liaison with other network elements. For example, uh, if a new data is being initiated by a device, then a PDU session is to be created. So in that case, AMF has to direct SMF, session management function, which we'll talk later, to actually create a PDU session for that uh, particular UE or device. And similarly, it has to talk to say UDM or AUSF during the initial access. During initial access, authentication happens. So in that authentications, although the anchor point is AMF there, but it will talk to UDM where subscriber profile is there. It will talk to AUSF for authentication. So it actually liaison with other network element to ensure that whether subscriber is actually allowed onto the network, and if it allowed, what kind of services or what kind of access it can be given. So it liaison with other network element also. So it plays a very, very important role in that sense. And as I said, authentication is one of the important role which so AMF directly doesn't do authentication, but it plays a key role in the sense that the device request for authentication is being passed through AMF itself. And for the first time authentication, it is kind of the UDM and AUSF which helps, and in subsequent AMF itself does a lot of functionality related to access. So let me ask one of you that in 4G or 3G network during initial access, many of you may be knowing that the device sends its IMSI. So can anybody tell me that what is the purpose of sending that IMSI onto the network? Any of you can just, yeah. Right, right, right. Correct, correct, correct. So in a similar fashion here, the equivalent to IMSI is called SUPI, subscription permanent identifier in 5G. So 5G, they have given a generic name as SUPI, SUPI, subscription permanent identifier, and there could be many type of SUPI. So IMSI is one type of SUPI. So in fact, IMSI will also be used in 5G, but that is a one type of SUPI. But the difference between say 4G, 3G network and 5G network is that for the first time registration, those IMSI is sent on a plain text onto the radio network. And you might have heard about the problem of IMSI catcher or somebody unauthorizedly intercepting a call. It was all because of the plain text IMSI which we used to, or the network used to send during initial access authentication to the core in 4G and 3G, and there was a problem of IMSI catcher. In 5G, what it does is it actually encrypts the IMSI or the SUPI through a agreed arrangement with the core, which I'll talk about that in some other session. And encrypted SUPI is called SUCI, SUCI, subscription concealed identifier. So that is sent to AMF. But AMF cannot actually decrypt that, because the key to decrypt, the private key corresponding to the public key which is used for encryption by the device, is not with AMF, it is actually with the UDM. So here UDM, so it interacts with UDM, wherein UDM decrypts with the private key, and then it gets the actual SUPI or the IMSI which it communicates back to AMF. So now, so that is one function where AMF plays a key role. That's why we are saying that it plays a key role, because other network elements are also doing. So can anybody recall TIMSI? What was TIMSI in 3G, 4G or 2G? Can anybody recall, tell me what was TIMSI? Yes. Yeah, so basically what used to happen in 4G, 3G, 2G was that although for the first time registration onto the network, it used to send a plain text IMSI. That was a problem, but subsequently what used to happen is that the network used to allocate a temporary ID to the device, and now onwards the device used to send, or mobile used to send the TIMC, the temporary ID, and network was able to resolve that yes, it is the same IMSI which is trying to interact. In 5G, that is called GUTI, Globally Unique Temporary ID. It is equivalent to your TIMC. So it is called GUTI. So those allocation of temporary ID, why I am discussing that? Because the allocation of that temporary ID is done by AMF itself. Access and mobility function does that. So what it does, just to explain, that when, as I said, that initially device is sending SUKI, and then AMF is sending that SUKI to say UDM, and UDM is able to kind of decrypt and know the IMSI or SUPI, and that SUPI is sent to AMF after authentication function is done. Now AMF creates a temporary table where it writes a GUTI, that is temporary ID equivalent to TIMC, and that particular SUPI. So subsequently the device will send only the GUTI, and AMF will come to know the SUPI because it has a mapping. So the temporary ID is allocated by AMF in 5G network. And for what purpose that temporary ID is used? Whenever a device is trying to access core, it has to identify itself, so it sends the GUTI in place of SUPI and SUSI. So SUPI is never sent on network because of the privacy and security. It was SUKI, and SUKI is also not sent all the time. It is the GUTI which is sent, and GUTI is allocated by AMF, and GUTI is also temporary in the sense that don't think that once a GUTI is allocated that will remain for that particular device. AMF keeps on changing GUTI from time to time in different scenarios, which we'll cover in some other session. So it plays a key role in authenticating the subscriber and allocating the temporary ID. And while paging also, those GUTI is used. When a device is paged, that time also AMF uses the GUTI, that temporary ID allocated to the device. Okay, so I think this is the major function of AMF, and these are also jotted down in this slide. When I'll say, perhaps you can go through the text part because it will be easier for you to read if you're not going to the recorded video. So now as I said that this plays a key role in mobility. So just a scenario, a very brief scenario, that suppose a device, say this car, is connected to this gNodeB, and it is kind of a moving and then it has to hand over to the other target. So this is a source gNodeB, this is the target gNodeB. So how this mobility takes place? So basically UV keeps on measuring the signal strength coming from different gNodeB, and whenever it decides that now handover process to start, so and actually the decision is taken by the target gNodeB. This particular device, after measuring, it sends the report, we call it RRC measurement, and then this gNodeB takes a decision that handover decision that handover to start. So just look at this particular flow. This is your source gNodeB, this is target gNodeB, and this is your AMF. There can be more than one AMF instance, but at particular time one AMF handles the call of one user. So that measurement and report goes to the source gNodeB, and handover decision is taken, and handover request goes to the target node, and target node acknowledges, and then handover triggers happen, and then this all those context transfer at that point of time, what all was the context is also given to the target gNodeB, and path switch happens. So path switch happens, and finally uh, uh, it handovers to the other gNodeB. So this is how, in a very very broad sense, handover process happens. So now let us look at various interfaces which is required for AMF to interact with various network element. As I said, this particular architecture which I am currently showing to explain the functionality is called reference point architecture, because these are the different reference connectivity which is named. So you just look at here AMF, that it has interface with UE called N1 interface. Just remember, this is called N1 interface. So although it is shown directly, but it goes via gNodeB, because UE connectivity is only through the gNodeB, but it actually communicates directly with AMF for all those access and mobility aspect. And gNodeB gets connected to AMF on N2 interface. Similarly, this, as I said, that AMF need to give command to SMF to create or modify or remove a PDU session. So there is an N11 interface, and AMF, as I explained, that also interact with UDM for during initial access and other purposes. So it has got N8 interface. So, and then it has to also talk to the policy control function, because whether a particular policy is to be applied to a particular device or not. So there is a N15 interface. So you can just look, it interacts with, I mean, most of the other network elements in the 5G control plane. So moving forward to session management function. So this a little bit I explained while explaining the network function of AMF. So this is your SMF, and let's go to the functionality it has. So as I explained that this, as the name also suggests, SMF, session management function. So basically the blue color pipe which I shown you in the earlier diagram was a PDU session. So the creation of that PDU session or modification of that PDU session, or say removal of that PDU session, is done by SMF. So basically if you look at SMF, it has, since it is sitting on the control plane, in the sense that it manages that particular UPF, it gives command to actually UPF to actual creation of PDU session happens through UPF itself, so it gives command for that. So the quality of service which we talked about initially, now it will come handy to understand. As I had explained that every data traffic will require certain type of quality of service depending upon the service as well as what I have subscribed to. So a particular rules are to be applied onto the UPF and all, because when suppose from an application data is coming, if there is an application and data is coming, it will come to UPF from application side, and then UPF need to actually kind of filter that data and apply a proper QS flow. So all those rules to UPF is actually given by SMF, and it also gives actually rules to the UE for packet filtering onto the upload side to apply a particular quality of service. So it plays that role also, and for that it has to actually interact even with the policy control function, and so it interacts with policy control function PCF, and from there it also gets data network profile and which kind of service has to be applied. And next part is that which UPF in a 5G network there could be many UPF user plane functions. So which UPF is going to serve a particular user? So UPF selection is in fact done by SMF itself, and even the IP address allocation is done here. So one is the session management, other it liaison with PCF, and the third is IP address allocation to the UE. So now let me ask you a question. So is allocation of IP address to a device or UE mandatory, or it is optional? Can somebody answer this? Yeah. Yeah, so tracking is a different subject, and perhaps that will be taken care, and a lot of parameter, even IP address becomes one of the parameter for tracking. So here question is that, what I wanted to explain, yeah, somebody else, please go ahead, come again. Okay, right, and anything else? If you recall my initial slide, I said that 5G data network in 5G is not PDN, it is the data network. So that means the traffic could be IP traffic, and then you definitely need to allocate IP address, otherwise the data flow will not take place. But it could be even a structured data. In case of a structured data, there is no requirement of IP address. So IP address in 5G is a kind of a, if it is an IP traffic, then only the SMF allocates IP address. So that's the answer I wanted to hear, right? Okay, and it selects the UPF, I had already explained. And the traffic steering, which I explained a little bit, that basically if you look at UPF, all those traffic forwarding to the data network is done by UPF on N6 interface. So these are the function of SMF which I explained. So so let us have a look at how a PDU session gets created and how the SMF plays a role. It's a very simplistic explanation taken from the document. So UV, actually it is the UV which request, if you look at here. But even before UV, let me tell you, so one more network element to understand, which is called NRF. Although I'll be explaining it later, but for this slide let me explain. So NRF is network repository function. Network repository function. So what it does is that whenever a new network element is rolled out, so it registers itself with NRF. When it registers, it means that NRF will have IP address or domain URL kind of that network element with this, and other network element will discover from this element. So that means they have to query this to know address of a network element. So what happens initially, when a SMF come into picture, it registers itself onto the NRF. So now NRF knows the SMF various, there could be n number of SMS address, and then so SMF is kind of created in NRF, address is there, so it knows. So when there is a session establishment request, is a request for creation of a PDU session by UE, then what AMF does is that it makes a discovery with NRF that which are all SMF active as of now. So it gets a list of SMS along with their IP address or domain URL, and then it decides which SMF will actually handle that call, and then it actually tells that particular SMF to create the PDU session. And once PDU session is created, a completed command goes to the AMF. So this is how a PDU session gets created in a very simplistic way. Okay, so let's move to different interfaces involved with SMF. So as you can see here that so SMF has to give direction to UPF for creation of PDU session, steering of traffic, maintaining quality of service. So it has a connection, reference point connection, that is called N4 with user plane function, or it takes command from AMF, so it's connected on N11 interface, and then it also takes data from UDM, because UDM contains the subscriber profile. So it must know that which kind of service is allowed to a particular device or mobile. So it also connects to UDM on N10 interface, and it also gets connected to policy and charging function, because it gets actually the quality of service details PCF gives to SMF, and based on that SMF applies that quality of service through UPF and through the devices in downlink and uplink respectively. So it has connection N7 with the PCF. So these are different interfaces which is used by SMF, which I have written in the slide. You can read if once I share that with you. Now let's come to the user plane function, UPF. So UPF, this particular, yeah, please go ahead, sir. That is called signaling part of it, sir. It's not for the data traffic, but for the signaling. No. As I explained this, that although it is shown directly N1 interface, but it goes through gNodeB. But communication is directly to AMF in case of this signaling. You got my point? Signaling part. Because data traffic has to flow in the user plane only. As we had explained that in 5G, there is a complete separation of control plane and user plane. So data traffic here, and control is done by all other network element, and it has, so the only connection to the control is the AMF for the UE. No. So user plane will start from UE to gNodeB to UPF and then to the data network. The blue pipe which you are saying is a kind of the connection, it's a part of user plane. And in core network, so earlier if you recall 4G, there used to be serving gateway which was connecting to eNodeB, and towards the data network PDN, you had a PDN gateway. So those were also doing the user plane function part, but they were also doing certain control functions. So it was a mix of control and plane user plane function being served. In 5G they have completely separated out. Right. Because there is no other way. It has to communicate wirelessly, which can only do gNodeB. But since communication is direct to AMF, it's called NAS signaling, sir. NAS signaling, which although passes through this, but it is meant for the core, not for the gNodeB, in fact. Right. So physical connectivity will be here itself. There is a physical connectivity between gNodeB and the core. So the physical connectivity used will be from gNodeB to the core only, but it says altogether signaling which directly goes to the AMF. Okay, so now user plane function. So as I said, this one. So basically let us see here that suppose the user is moving from one gNodeB to other gNodeB. So gNodeB is actually changing. AMF is remaining same for control part. For data traffic part, for the PDU session, UPF generally remains same. So we also call UPF as the anchor point for NG-RAN mobility. If there is a mobility from one gNodeB to other gNodeB, UPF remains, the PDU session moves from one gNodeB to other gNodeB, but the UPF remains same. So that is one of the function that it continues the PDU session whenever even a gNodeB is being changed because of the mobility. And second, as I said, that it receives command from SMF for giving a particular quality of service flow for particular data, and also the policy enforcement part. So policy will come through the SMF, the PCF will give it to SMF, SMF will give to UPF, but the actual implementation of those policy will be done by user plane functions. So in addition to those packet forwarding towards the data network, these are the other aspect which is taken care by UPF. So if you look at, as I explained, it is an anchor point for NG-RAN mobility, and it also ensures the quality of service for which it receives command from SMF, and then it also implements certain kind of policy on a dynamic basis, in the sense that if a user is there in an area where there are no resources, so there may be UPF can receive a command that please throttle the data or limit the data to this user. So throttling of data could be one of the example. So the dynamic implementation of the policy is also done by UPF onto this side. And packet routing and forwarding is one of the important functions. So here one more thing which I wanted to explain, that so now let me take pen here, and then so what I just wanted to explain is like suppose this is UPF. So after that you have a data network, and this data network could be, say, internet, or there could be other data networks, say IMS for voice call, or there could be AR/VR kind of service, augmented reality service. So now all those data will come here, if user is here you have a user. I'm not showing in between item, so just assume this is a user. So of course you have a gNodeB and all, I'm not showing for simplicity. So if these data are coming, so one of the role of UPF here will be to identify that this data, then only it will be able to apply a particular quality of service, because for a voice call I require guaranteed bit rate, although the data rate will be less, but it has to be guaranteed. Signaling also, IMS signaling will also require kind of a specific quality of service. Internet will be best effort basis. AR/VR you require good latency, and you also require high data rate. So it's a different kind of service. So what UPF does, it filters the data. How it filters? It gets a filter rule from the SMF, and based on those rules it will be able to filter and apply a specific quality of service which I talked about, and apply a particular quality of flow ID onto the downlink side, right? And the same function for uplink is done by the device, which I'll talk. I have, I think, 2 sessions on quality of service. I'll try to cover in detail there, but this is in nutshell how the UPF function is there as part of managing quality of service. I hope I am clear up to now. So basically, one of the example would be that if a device is in an area where there are no radio resources, so I cannot allocate a frequency and time domain those resource element, because it cannot handle. Maybe it is slightly far away from the BTS. It cannot do kind of higher level modulation. Signal quality is poor. Although the customer is subscribed to a, say, high speed data, so if the network allocates the resource, full resource to that particular user, then also it will not be received, it will be waste of the resources. So there the dynamic policy which comes to UPF through SMF and PCF, because all those reporting happens, that please throttle the data for this user. Even if you give higher data rate, it will of no use, it will be wastage. So throttling of data can be done even if customer is kind of have subscribed to a higher data rate, and since he is in an area which the device cannot receive that much resources which not generally be given, so it will be throttling of data can take place. So that's what I wanted to explain. Is that clear? Pardon? Yeah. So decision will be taken by PCF, implementation is done by UPF. Right. Because it is sitting on the user plane, so all those implementation here, because data traffic is flowing through UPF, so implementation can only be done by UPF, rest all other can give command, right? Thank you. So those things are written here, so if you want to read, when I share the slide you can read. Let us see the interfaces here also. So you just see that as SMF gives various command to UPF, IP address allocation, so it is connected to SMF on, let me take the pointer again. So N4 interface, and data network, it gets connected to N6 interface. Earlier it used to be SGI interface in 4G, and from gNodeB you have N3 interface. There is one more interface which is not mentioned. So I mean in 5G you can have more than one UPF. There could be some intermediate UPF also, or branching UPF would be there. So the connection between the UPF, you have N9 interface, which is not mentioned here. Normally it is shown like this as an N9 interface. So these are the interfaces. Now let's talk about unified data management. This particular network element, what is the function? So when I was talking about AMF, I talked about UDM. So as I said that part of access authorization, as I said that when network receive SUKI, concealed subscription identifier, it is the UDM which decrypts. So so access authorization is, so it has got profile of all the subscriber. So profile of all the subscriber, not only subscriber but also the data network. As I said that in 5G I can have n number of data network. So it could be IMS, it could be AR/VR service, it could be internet, it could be a corporate LAN, right? So profile of every data network is also there in UDM. And when a UE is provisioned, there it is also provisioned that it has access to which all data networks, right? So it's not that everyone can access to AR/VR service. It's not that every subscriber can access to a particular service. It is based on subscription, right? So those profiles are provisioning is done in UDM itself. So access authorization is one of the function. It plays a key role. It keeps the data network profile. And registration and mobility management, it plays a key role because AMF is also involved. So as I said, what role it plays. So I explained this, that it contains the central registry of subscriber and data network profile, involves in access authorization, registration and mobility management, and it also tells, since it has got profile of the subscriber, it tells AMF and SMF, because we see that it gets connected to AMF as well as SMF, that what is allowed and what is not allowed, which QS profile or data network they can connect to. All those provisioning is done in UDM, and UDM knows that. So it tells AMF and SMF accordingly to take care of that. So this is the function of UDM. So I'll also give you some structure how data is stored in UDM in upcoming slides. Okay. So these are the interfaces. So UDM interface, as I said, with SMF and also with AMF, during access authorization AMF, and during all those quality of service provisioning SMF it connects to. And now policy control function. So as the name suggests, it is for the implementation of even the dynamic policies are implemented by policy control functions. So dynamic policy decision, which I was just talking about, throttling of data, implementation is of course done by UPF through SMF, but the decision here is taken by PCF. So basically it can even alter a mobility or session related aspects. So what do we mean by that is that so as I said that during a session I have to throttle a data, or whether a particular device have that mobility provision into or not. So there could be different roaming scenario, mobility scenario. So what is allowed or not allowed, all those policy decisions are taken by PCF. So which the second one, throttling of data, I have discussed. And then the resource allocation, so it also takes important role in allocating a correct resource to a particular device or mobile. So now this is a 5G core network, but let me tell you that this network architecture which I shown is a reference point architecture. Practically implementation will be service based architecture, but for understanding of every network element, reference point architecture is kind of a way to explain. So I explained in that sense, and now onwards when I move to service based architecture, my focus will be to explain that. So for today I think we have completed our session. It's already 4:28 also. So now I close the PPT, and I request all of you to you can open the mic and have a small discussion, so that if there is any doubt or anything we can take care of.